This is a quad 2-input AND gate integrated circuit chip, and you could tell all that just from these two numbers right here. This 08 tells you that this is a quad, meaning 4 2-input AND gate chip. In other words, this chip contains 4 2-input AND gates. Well, these other letters and numbers tell you stuff about the chip as well, and we're going to take a quick look at that. So the first two letters just tell you who made the chip manufacturer. In this particular case, DM tells you the chip was made by Fairchild Semiconductor, but we're going to use a bunch of chips in this class, and you'll see some of them will have SN that tells you it's made by Texas Instruments and other manufacturers as well. Certainly you do not have to memorize this. The next two numbers tell you about the technology of the chip, and actually these two letters do as well. In this class, we're going to be using TTL or 7400 series TTL chips. The TTL is, as I said, it's the technology that's used to make the chip. It's just like saying if you drive a car, it may be a hybrid or electric or an internal combustion engine car. It's different technology to make the car, but it's still a car and it still drives the same way basically. Has the same function. These next two letters, again, are sort of a subclass of TTL. It's a little bit more about the technology that's used to make the chip. Again, in this course, we're going to be using what's called low power Schottky. The next two numbers, we already talked about this, tells you what the chip does. And the very last letter tells you the package style. And more about that in a slide coming up. So again, in this course, we're going to be using TTL chips. This is how they're made out of transistor logic. This is a little bit about the construction. You don't have to memorize this, but I have seen questions that ask you about an advantage of using the type of chip that we're using in this course, which is TTL. It's faster than the other type. It's not sensitive to static electricity. And disadvantage is it uses more power consumption than the other type of chip, which is the CMOS chip, which is the type we're not using in this class. And again, you can read about advantages and disadvantages. This is the technology that's used to make this chip. It's constructed from metal oxide semiconductor technology. And there's some advantages and disadvantages of this type of chip. You can read through that if you like. The subclass of chip that we're using in this course is called a low power Schottky. You're not going to get any questions about this, but that's just what this LS stands for. And there's other subcategories of chips. And actually, you will see some without any letters in between them in this course. The package style of chip that we're using in this course is called dual inline package, or DIP. Sometimes referred to also as through-hole technology. Again, the chips that we're using in this class, they have these little legs on them, and they're meant to go into breadboards. Dual inline. There's two lines of little pins that go into breadboards. There are, of course, other types of chips that we're not going to be using in this course called surface mount technology chips. These tend to be smaller. They're meant to mount to the surface, obviously, of a board rather than into a breadboard. And you'll see, like, if you opened up your computer, it would be full of surface mount chips as opposed to the dual inline package chips. And of course, there's advantages and disadvantages of each type. The types of chips we're using, the through-hole technology or DIP type of chip, they tend to be chip and dip. Yeah, they tend to be a little bit bigger. They're easier to use for breadboarding, but of course, a disadvantage is also that they are bigger. So I don't know. And there are advantages and disadvantages to the surface mount chips as well. But mostly the advantage to the type of chip that we're using is they're bigger and they have the little pins that go into breadboards. So they're typically used for prototyping or breadboarding. In this class also, we're going to be using a variety of density of integrated circuits. In other words, chips can also be classified by how many logic gates are on the particular chip. And in this course, we're going to be using small scale integrated circuits and medium scale integrated circuits. These are chips that contain up to 100 logic gates on them. But of course, if you buy a computer, you might see chips with thousands or tens of thousands or even millions of logic gates on them. If you buy an Intel Core i5, it has many millions of logic gates on that chip. We're not going to be using that in this course, but it's really all built up from transistors in the same way. Pretty cool. But we will be using SSI and MSI, small scale integrated circuits and medium scale integrated circuits in this course. If you really want more information about a chip, you can look up the manufacturer data sheet. If you just go to Google and type in a chip number and manufacturer data sheet, you will get a crazy amount of information about the chip. You'll get a general description. It tells you, like if you Google DM74LS08 data sheet, it'll tell you basically what the chip does. It'll tell you the little connection. It'll give you a little connection diagram, how to connect it with inputs and outputs, power and ground, and so forth. It'll give you the little truth table. L means this is like low or zero. So if you input 2 zeros, you get an output of 0. It's an AND gate, obviously. So the only way you get a high from the output is if you input 2 highs. 1, 1 gives you a 1 as an output. It'll tell you all sorts of other things, like what the voltage. I know you think of low as voltage 0 and high as voltage 5, but that's not really true. There's a range. And for this particular chip, it tells you that anything of logic 2 or above will be interpreted as logic high. Anything from 0 to 0.8 will be interpreted as logic low or 0. So there's lots of other information you can look up. Electrical characteristics, switching characteristics. Oh, this is kind of interesting. You can look up propagation delay. You think of these chips as working instantaneously, but they really don't. There's a little time delay between when a signal goes from the input to the output, and it's measured in nanoseconds. So it's a few nanoseconds for a signal to actually go through a chip, which doesn't seem like much, but if you're building a computer, I mean, this is, this does all add up after a while. A few nanoseconds here, a few nanoseconds there, it adds up. The manufacturer data sheet also contains information about the physical dimensions of the chip as well. So lots of information you can look up if you want to. And this PowerPoint is included right underneath the video, so you can check that out if you want to go through it on your own. Okay.